So today we are going to discuss about metals and some of the early theories that was originated to describe metals. So metal we all know is a very good thermal and electrical conductors. Generally, metals are, and there are so many metals in the periodic tables. And to understand about them, we need to understand more about solids. So many solids are metals. So to understand about them, we need a theory and also to understand about non-metals we should know about metals. So uh, so around 1897, J.J. Thomson discovered electron, right? And after that, around 1900, P. Drude, there was one guy who named P. Drude. So he came up with the first theory of for metals, and that is called the Drude theory for metals. And in this video, we are going to know about the basic assumptions that Drude made for describing metals. Uh, so first of all, that it was known that the metal. So the first was that metal was seen to be neutral, but it was thought that the reason behind this conduction is the particles called these electrons, which are negatively charged particle but as a whole the metal was neutral. So J.J. Thomson, so the Drude thought of that there must be some kind of positively charged particles, but which are much heavier much heavier than the electrons. So actually you can imagine the picture to be like this. So this is like the so this much heavier particle, this is like the ion core. So in an atom, this ion core will be the much heavier portion, and this outside some electrons will be there, which will be reasonable for this conduction. That was thought by Drude, but he didn't have that much of idea of what is the nature of this immobile positively charged particles, or what is the nature of these mobile electrons. He didn't know that much of things, but he basically considered like there will be a hard core which will not be moving, but it should have a positive charge to make the atom as a whole charge neutral, and as the total metal to be charge neutral, and there should be some electrons outside of this charged core which should have this negative charge and which will do the conduction work. So he thought of like these electrons, they uh, so like these valence electrons. So some of these valence electrons actually contribute to conduction. So they are like some weakly bound uh, electrons to this core of the ion, and they just wander off and move throughout the material to give rise these properties. So suppose you have Z total electrons and Z tightly bound electrons. to the core. So this ZA minus Z will be your conduction electron. All right. So roughly this number is around 10 to the power 22 per centimeter cube. And now to so this is the roughly this mean numbers of electrons are generally take participation in the conduction, and to describe this the conduction, he considered to describe this, he used the classical theory for gases, for neutral dilute gases. Although the concentration of electron gas is around 1,000 times higher than the dilute neutral gas, but still he assumed that uh, assumed it to be like a classical electron gas, and applied that theory to describe the theory of conduction in metals. So that is one of the thing, and though it is a charged gas, but yeah, and he thought of like these electrons are a like a spherical particles which moves in a straight line in between collisions, and that too he considered only the collision of these electrons with the heavier particles. So to say what is the first assumption, so one thing is called independent electron approximation, and another thing is called free electron approximation. So in independent electron approximation, there is generally no electron interaction considered, and for free electron approximation, there is no electron ion interaction. So these are the main two approximation within the first approximation, and as we see, actually this electron approximation is interaction is not needed to describe many of the phenomena, but in no cases we can consider this free electron approximation, so this has to be discarded immediately. So in some cases, to have a gross idea about a solid, before applying the more sophisticated theories, we sometimes apply this kind of Drude theory just to get a feel of that metal. But this free electron approximation is very dangerous, and this has to be discarded immediately. Although this independent electron approximation is fine in some cases. So this is one thing. And then the scattering origin. So this, he never questioned about the origin of the scattering, that there can be this electron scattering, or this, he only considered that electrons are like scattered from this heavy core, and he didn't question about the nature of the what is the origin of this scattering. He didn't question about those things. And another thing is, he considered that there is no force. When there is no applied force is there, then the electron moves in a straight line. The electron moves in a straight line, and when no force, no applied force is there, no applied force applied, suppose there is no electromagnetic force is applied on the electron, then it will move in a straight line. And when force applied, it will follow, the individual particles will follow Newton's law. So he assumed that Newton's law. He assumed that also, and no force is applied, and when force is applied, it will follow the Newton's law. And so there was this parameter that he considered this tau to be relaxation time, which is called relaxation time, which is the time between two successive collision. So 1 by tau is the probability of collision per unit time, right? So this is the one thing, but he never questioned about this. He took this tau to be uniform and independent of velocity and position of electron, which is also, to some extent, it works fine. And then for the last, the fourth one, the fourth assumption is the thermal equilibrium. So he assumed the thermal equilibrium is achieved by collision between electron or core or whatever. So by collision, this thermal equilibrium is achieved. So before a collision, the velocity before collision is different than after collision. And after collision, the electron randomly goes off, and it could be in any direction. And so if a region is thermally hotter, that might have greater velocity. So it is completely determined by this thermal factor. So these are the kind of these basic assumptions that Drude made uh, while constructing his theories. We'll later learn more about this material and this condensed matter theme physics, and for today this will be all. Thank you.